Welcome to my video course on engineering FRMCs, where we will explore the massive technological shift currently rewriting the rules of global transport networks. If you've ever found yourself wondering how modern trains are evolving from these giant mechanical beasts into highly intelligent, data-driven machines, well, you are in exactly the right place. Today, we're going to completely break down the blueprint of how railway communications are taking a literal quantum leap forward. Okay, here's our game plan for today's explainer. We're going to cover the fall of GSMR, look at the intense data demands of tomorrow, dig into the FRCMS 5G solution, check out the UIC program milestones, and finally map out the global migration timeline. Let's kick things off with Section 1, the fall of GSMR. To understand where we're going, we really have to look at the core problem with our current setup. Picture this. You're trying to stream a 4K movie on a clunky 20-year-old 2G flip phone. Doesn't work, right? Well, that's exactly what's happening with GSMR. It was absolutely groundbreaking in its day, but it relies on highly modified, bespoke equipment that simply cannot handle today's massive data volumes. It's a voice-focused, circuit-switched relic trying to survive in a world that absolutely demands high-capacity, all-IP architectures. So what does this all mean? It means this isn't just some optional, nice-to-have upgrade. It is a mandatory survival requirement. Between the hardware reaching the end of its life cycle and the highly constrained radio spectrums we're dealing with, legacy rail networks will literally hit a brick wall if we don't overhaul the foundation right now. That brings us right to Section 2, Data Demands of Tomorrow. The trains of the future are essentially rolling data centers, and the heavy-duty applications running on them are what's driving this desperate need for bandwidth. We're talking about remote driving for emergencies, continuous high-definition video surveillance, and massive sensor networks checking track conditions in real time. Systems like the European Train Control System and automatic train operation simply cannot function safely without instant, zero-latency data. These aren't just cool sci-fi features. They are the absolute foundational building blocks for digital rail operations. And all of these applications are pushing us toward one ultimate goal: grade of automation 4. GOA 4 is the holy grail of rail tech, where trains essentially drive themselves, without a human in the cab. To pull that off, our infrastructure has to instantly communicate massive amounts of telemetry. In a GOA 4 scenario, traditional human voice dispatching takes a backseat, and ultra-reliable machine-to-machine data completely takes the wheel. Legacy networks would choke on that kind of data load in seconds. Which leads us to Section 3, the FRMC I5G solution. Enter the technological savior of our railway networks. FRMCS, or the Future Railway Mobile Communications System, is the mission-critical 5G smartphone upgrade this industry has been waiting for. Built natively on a 5G backbone, it pushes data speeds up to 10 gigabits per second while keeping latency virtually non-existent. It is the wide-open, ultra-fast highway that all those futuristic automation applications are going to drive on. Now, the true engineering genius of FRMCS is under the hood. It features a brilliantly layered, modular architecture. It cleanly separates the transport stratum, the service stratum, and the railway application stratum. Why does that matter? Because it means the underlying radio network can be updated or even entirely swapped out over the coming decades without ever disrupting the mission-critical applications running on top of it. It's a total game-changer for system resilience. By leveraging an all-IP 5G foundation, the advantages are just massive. We allow trains, trackside sensors, and predictive maintenance networks to seamlessly talk to each other without any bottlenecks. It even opens the door for things like intermodal communication. Imagine autonomous cars and trains instantly talking to each other at a rail crossing. Plus, because it uses standardized commercial 5G tech, it drastically lowers the total cost of ownership compared to all that expensive, bespoke hardware we used to rely on. Let's move on to Section 4, UIC Program Milestones. You might be wondering how we actually pull off a global shift like this. Well, the International Union of Railways has laid out a highly rigorous roadmap. At the end of 2023, version 1 was officially published and tested. Right now, the industry is pushing through version 2, finalizing it for real-world validation. And everything points toward the definitive version 3, known as the first edition, which is heavily targeted for completion by the end of 2026. Hitting that version 3 milestone requires an absolutely immense specification ecosystem behind the scenes. Every single onboard application, from voice apps to automatic train control, has to be perfectly harmonized and mapped directly into standard 3GPP telecom models. And yes, that's the exact same global standards body that governs the commercial mobile network your smartphone uses right now. This effort guarantees true cross-border interoperability, so trains can cross international lines without missing a beat. And finally, Section 5, the Global Migration Timeline. With all the engineering specs meticulously mapped out, we have to ask, how does this actually roll out into the physical world? Ripping out decades of legacy infrastructure isn't going to happen overnight, obviously. It requires careful parallel operation of both old and new systems. But make no mistake, a hard deadline is rapidly approaching. 2027, that is the critical target year. When that FRMCS version 3 first edition gets finalized, 2027 is widely reputed to be the start of massive real-world deployments across Europe. This is the year the technological tide officially turns. But we also have to be realistic. The architects behind this system know that not every single country has a mature 5G infrastructure ready to go. And for those global regions, there's a really clever 4G-based transition model called FRCST. Because 4G also utilizes an all-IP architecture, it can act as an essential stepping stone. It supports mission-critical services today, ensuring the whole world can modernize now, and then seamlessly transition to 5G via simple software update down the road. To wrap up this explainer, I want to leave you with this final thought. When the trains of tomorrow operate completely without human intervention, guided by an invisible, ultra-reliable 5G web, how will this flawless engineering reshape everything we know about travel? The obsolescence of our old networks isn't an end at all. It's the vital beginning of an era where our transport systems are as smart, fast, and seamlessly connected as the data flowing through them. Thanks for joining me today. Keep exploring, keep learning, and I'll catch you in the next explainer.